Day 14 on deck. Welcome back. If you're a Windows user like me, don't forget today was Patch Tuesday. Patch your machines. Day 14, Regolith Resort, distress signal. Alright, this little path behind a waterfall. Distress signal leads you behind a giant waterfall. There seems to be a large cave system here. Signal definitely leads further inside. Deeper ground, feel like unfortunately you're familiar with analyzing the path of falling material will come in handy. Scan station vertical slice the cave above you. Mostly air. Structures made of rock. Scan traces the path of each solid rock structure. Reports the XY coordinates that form the shape of the path. Vertical slice of the cave above you. Okay. So these are our spots. And two paths of rock. First path consists of two straight lines. And the second path consists of three straight lines. The first path consists of a line of rock from 498.4 through 498.6 to 496.6. Another line of rock from 498.6 through 496.6. Oh, sorry. Sand is pouring down into cave from 500,0. Drawing the rock as blah, air as blah, and the source of the sand as plus, this becomes. Okay. Sand is produced one unit at a time. The next unit of sand is not produced until the previous unit of sand comes to rest. A unit of sand is large enough to fill one tile of air in your scan. Always falls down one step if possible. If the tile immediately below is blocked, all right, if the tile immediately below is blocked by a rock or sand, the unit of sand attempts to instead move diagonally one step down and to the left. If that tile is blocked, it stands one step down to the right. And keeps moving as long as it's able to do so at each step possible. Down, then down left, then down right. If all three possible are blocks, comes to rest. Okay. So the first is like a little Tetris thing. Drops all the way down to the bottom. Then this one drops and drops left. This one drops and drops right. This one drops and stops. Right, then this one gets here, goes left, goes left. Okay, once all 24 units of sand, all further sand flows out the bottom, falling just for fun, the path you sand before falling forever. Okay, I see. Using your scan, simulate the falling sand. How many units of sand come to rest before the sand starts flowing into the abyss? All right, so we have a few things that we know here, right? Which is sand runs down, then down left, then down right, or lastly comes to rest. We need to know the extent of the rock in terms of, so this is 0 and then goes downward in terms of maximum y, right? Need to know the extent of the rock in terms of minimum and maximum x. Right? So we've got that. And let's take a quick peek at our puzzle input. All right. It's a huge amount of stuff. A huge amount of stuff. Okay. Well, that's fine. We'll come back to you in a minute. We'll do the simple one first, right? And all right, so first things first, let's fill out the cavern, right? So what we need here is every one of these needs to be all right, for each of our row, I don't know, it's in row in data. I kind of feel like I want to scan this twice and find my extents, right? Let's see, lines are going to be equal to row split, right? So this is going to be coordinates. So this is going to be split this with a select of an int parse to array to array, I think. So our coordinates are going to be blah, 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 blah. Okay, so those are x, y. Right, so max y is going to be 0. Min x is going to be int min value. Max x is going to be, actually this is wrong, this is bad, this is backwards. Int max value, okay. So all that's fine, right? So then for each of our coord in coords, we'll say if coord 0 is less than min x, then min x is coord 0. Else is, we don't have to do else, we can do if. If coord 0 is greater than max x, then max x is coord 0. All right, and then if coord 1 is greater than max y, then max y is coord 1. Well, let's do a quick console write line of extents. X is min x to max x. Y is 0 to max y. All right. Let's do that real quick. So 494 to 503 and 0 to 9. 494 to 503 and 0 to 9. So that all looks okay. This, I think we can do this. I think we can do this, right? And then data is going to be arrays of int arrays. Yep. No reason for us to parse that multiple times. 494, 503, 0 to 9, good, okay. Then we're gonna we need to make a grid. which has inside of it, let's do enum occupant. It's going to be empty, or it's going to be rock, or it's going to be sand. Sure, sand. Okay. Now we'll go through the coordinates again. All right, and then what we're going to need to do is, you can be up there. We're going to need to draw these. Oh, so we also need occupant array. Cave is occupant array is a new occupant array where we have let's see, max x minus min x plus 1, comma max y plus 1. Okay. And those are all empty by default. So that this array will be empty. All right, so then set of coordinates. So we have current is going to be coords 0. IDX is 1. IDX is less than coords length. Double plus coords, right? So we're going to go from double plus index. We're going to go from one space to the other, right? So current is going to be coords 0, 0, coords 0, coords 0, 1. That's our XY. Target is coords index 0, coords index 1. All right. And then we'll say while current is not equal to target, we need to know which direction to go, but for the moment, what we're going to do is we're going to say occupant of current item 1 minus min x is cave, occupant rock, right? Current item 2, so that doesn't have to get subtracted by anything because minimum 0. So that's a rock occupant. And, oh yeah, this is comma. So that's a rock occupant. And then we need to move current towards the target. So we want direction of x is going to be math min of 1 comma, let's do math max, right, of that, and then the math max of -1 and chords 0, current item 1 minus target item 1. That's direction Y. And then I want to do this console right line, moving from, let's make sure my math is right, moving from current to target with steps of dir X, dir Y. All right. Steps of 0, 0. That's wrong. Yeah, so I definitely did something wrong there. Oh, this is item 2. So 0, -1. That's wrong. We probably need these to be reversed. Right, because we want to go in the direction of the target, not in the direction of current. All right, so you're going to go up 1. You're going to go 498.4 to 496.6. That would be -1, +1, sure, even though that's not actually how it works. Okay, so that's all right. So we say, well, current's not equal to target. We do this, right? Which is you get marked, and then current item 1 plus equals dir X, current item 2 plus equals dir Y. All right, and then let's print the cave. Let's put print cave down here, void print cave. For var X is min X, X is less than less than or equal to max X. Actually, yeah, that's fine. That's fine. Double plus X. All right, for var Y is min Y, as min Y is already 0. Y is less than or equal to max Y, double plus Y. Let's make sure, are we doing this in the right direction? We want to go up X first, so we want to go backwards. Yes, we're going to say console.write occupant to char of cave at X minus min X Y. And then here we're going to do console.write line var occupant to char of occupant. This is actually a character. You're going to return occupant select. Select occupant. Occupant switch. Why am I doing select? I know it's switch. So empty is a dot, right? Is that what we did? Dot and that and that. So dot occupant empty is that. Rock is this. Sand is this. So let's print the grid. That looks very much correct, although why is that like that? And this is wrong as well. Oh, we forgot to mark the very first spot. Right, so we need to do this. That didn't help, huh? Is a rock occupant. That's the target. Oh, that's probably why. I'll mark it after we move. Okay, that looks better. So there's our rocks. That looks good. Okay. I am okay with all that. So what we need now is to start running the sand, right? All right, so the current sand, we don't know. Well, we really don't know what this is yet. I'll just do while true. Let's see, current sand is 500, 0, right? All right, so that's where we start. So while true again, we're going to try and move the sand. So we're going to say if the cave at current sand item 1 minus min x, comma, current sand item 2. So we want to go down 1. So if you're empty below, actually down 1 is plus, not minus. So if you're empty below, then down you go, right? Then current sand item 2 plus plus. Else if, and then we want to check this exact same thing, except we want to go 1 to the left. We need, before we do that, we have a bounds check here, right? Our first bounds check is fall off the left edge. Right, so if current sand item bool finished is false, so while not finished. So if item 1 is less than or equal to min x, right, then that means we fell off the edge, right? So you're finished. So finished is true, and we get break out of there, and then that will break us out of here. Right, and then we check the left edge. So if the left edge is empty, then we're going to do, all right, current sand item 2 plus plus, current sand item 1 minus minus. Else, now we also need to check if we're going to fall off the right edge. All right, we're going to do all of this except the other direction. So if you're greater than or equal to max x, then we finish. Otherwise, we're going to look at +1 and double plus. And so out of here, we're going to say if we're not finished, then we need to record the final resting place, right? So the cave at current sand item 1 minus min x, comma, current sand item 2 is occupant sand. And we're going to say console write line sand stopped at this. Right? Pre-compute. All right, so here we are. We're obviously in an endless loop here somewhere. Let's go take a look and see what's going on. Okay, so we're 500 and 0. Oh, look at all my watches from last time. Give me my locals instead anyway. All right, so autos are actually probably better, right? So that occupant was empty, so current sand item 2 plus plus, which means we keep going. We're now at 500 comma 1, 500 comma 2, 500 comma 3, 500 comma 4. This is what we expected. Oh, hey, where'd my browser window go? All right, browser. Lost my browser window. I don't know where you went, buddy. Yeah, you're supposed to be here. Right, so it's going to fall all the way down to, looks like 1, 2, 3, 4, 5, 6, 7, 8. You're going to fall all the way to 8. Okay. All right, so where are we right now? We are at 5, 6, 7. Okay, I guess that's 7, not 8. Although this edge goes along 9. So what are we? Current sand, what are we? Oh, we are at 8. Okay, good. We forgot to break out of here, right? That's what we're missing. We're missing to break out of here. That's why. Okay, so stand stopped at 6, 8, 5, 8, blah, 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 blah. So we've got a bunch of things there, right? And our goal is to count how many pieces of sand fell. Let's print the cave when we're done. Print the cave. Let's make sure the cave looks like what we expect it to look like. All right, that does look pretty close. All right. So yep, full there, and then down, down, and then there, and then there. So that all looks good. So the last thing we need to do is we need to count how many units of sand come to rest. So every time an item of sand comes to rest, we need to count that. Right, so result plus plus, return the result. Okay, so that's 24. 24 units. Okay, let's try with our real input. It's going to be an interesting cave, isn't it? I'm kind of curious to see what's going to happen when we try and print this thing out. Okay, well, we broke something. So we were, all right, actually that's okay. Where did we fail and why? We printed the cave. So the cave was created. We've got an out of range on 73. Index out of range on 73. Index out of range on 73. That should never happen, right? So we'll take those away because we're pretty sure those were all okay. Console write line, console write. We're gonna do this, which is current sand. All right, let's see what it does. Making a lot of steps. 578, 171, huh? 578, 171. 578, 171. I guess it's possible that we could exceed y here, right? So if current sand item 2 dot, let's see, is, because 171, we did not print, we did print the extents. All right, so let's stop this for a moment. So 171 is our extent. So it's very likely that what's happening is we're falling off not a right or a left, but directly off of the bottom, right? So then what that would mean is if current sand item 2 is greater than or equal to, is greater than max y. Is it greater than? I think it's greater than, right? Then finished is true and we break. We still have an index out of bounds, but in a different place now, 81, so that's here. All right, so let's do this. Let's run this in a debugger and have it break out for us. Okay, so the current sand is 578, 171. 578, 171, so we're definitely off of the 578, 171. Yeah, so if we're all the way on the bottom edge, then yeah, so I'm just, this is off by 1, that's fine. Whatever, stop. We're off by 1, this is fine. All right, so there's one cave, there's another cave, we got 1068. Let's go see if that is our answer. 1068, it's good. Okay, what's next? There isn't an endless void at the bottom of the scan. There's floor, and you're standing on it. You don't have the time to scan the floor, so assume the floor is an infinite horizontal line with a y-coordinate equal to 2 plus the highest y-coordinate in your point scan. In the example above, right, floor is at 11. With the added floor, okay. To find somewhere safe to stand, you'll need to simulate falling sand until a unit of sand comes to rest at 500, 0. Blocking the source entirely and stopping the flow of sand into the cave. In the example above, the situation finally looks like this after 93 units of sand come to rest. Using your scan, simulate the falling sand until how many units of sand come to rest. Okay, so this is basically the same loop except slightly different, which is fine. The problem is we need to get a copy of the cave, right? Cave copy is cave dot copy to cave copy to array index. Copies all the elements of the current one-dimensional array. Okay, except it's not a one-dimensional array, right? Okay, copy to one-dimensional array that is the destination of the elements copied from the current array. Let's do this. I've got a better idea. This is the easiest way to do this, right? Cave 1, cave 2 is the exact same thing. And when we fill it up with rock. Oops, that was supposed to be a copy. Okay. Print cave requires a cave to print. Occupant. Let's see, we want occupant. Occupant. Right, occupant, double array, cave. All right, so you're a cave. Cave 1. Cave 1. Actually, let's print cave 2, because the other thing we're going to do for cave 2 is that's kind of an interesting part of the problem, though, isn't it? We can basically just keep a list of these. These are the row below. Given the size of the caves that we have, I don't know how easy that is. So the interesting thing about this is we know that the largest it could possibly get is based on how tall it is, right? So min x1 and max x1, and your max y1. Okay. Extents for cave 1. And then we're basically going to say the height. So max y2 is max y1 plus 2. And then we'll say the extents for cave 2. Be min x2, max x2, max y2. So we know the height is basically max y2, right? So min x2 is going to be the lesser of min x1 and 500 minus, we'll say 499 because we're just going to do plus 1 anyway. 499 minus max y2 divided by 2, right? And then max x 2 is math max min x, or max x1, and 501 plus max y2 divided by 2. Right, so in this example, it looks like they print a little bit more than necessary. So how long is this? Where's my PowerShell window? This length, so that's 25 wide. That's fine. So we'll do print cave2. We already did print cave2 down here, right? And then we're going to say for x is min x2, x is greater than or less than or equal to max x2, then we've got plus x. We're going to say cave2 at current x minus min x2. Current is the y is going to be max y2 is occupant rock. I think that's right. Let's not bother to print this cave anymore. We're not doing anything for part 2. Let's use the old data. This data is a little bit challenging to tell what we're after with. So that's supposed to be, okay, I definitely did that wrong. Because the extents were wrong. So this is backwards, right? So if you're 11 high, oh, no, this shouldn't be divided by 2, that's why. So print the cave. Rank. Number of ranks, nope. How about the dimension, right? Get the length in the first dimension. Cave, get the length in the 0th dimension. So that's going to be 0. That's going to be x and y. All right. So these are now less thans and not less than or equal to's, of course. All right, so the construction of the cave is still not correct because here we need to use x2, and here we need to use x2. So that's the cave. So it looks like we have 4 on this side and a shit ton on that side. Let's go take a look at what they had. So they have 5, but I think they're 1 wider than they actually need to be, right? And then on this side, they had 5 extra on that side. So we have 4, and we have 1, 2, 3, 4, 5, 6, 7. All right, so probably the math that I thought was wrong was actually right. So now we've got 6, and I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. Probably more than I need. What happens if I just do 500 and 500 here? All right, then I've got 5, and then I've got more than I need. But given this, I've got 5. All right, well, let's print cave. So let's go ahead and print cave 1 again when we're done with it, right? Print cave 1, right? Let's do this. Long fill cave, occupant, cave, min x, max x, max y, and you're going to return the count. So basically all of this right? So all of this, go ahead and print the cave. So this is max y. We're going to have a new condition here in a minute. Let me just fix up all of this. Min x1 is min x. This is the cave, that's min x. All right. And then this is max x. This is the cave, that's min x. And then this is the cave, so this is min x. So we have a new sand spot. So return results, right? So we're gonna have a new sand spot. A new edge case. So if our other edge case is if the cave at current sand item on min x current sand item 2 plus is equal to sand. So if there's already sand where we are, then that's another exit case. Right, so now we're gonna do fill cave 1, min x1, min max x1, max y1. Okay. So that's what the filled cave looks like. We knew that was what that one looks like. Let's see what happens here with fill cave 2, min x2, max x2, max y2. Let's see what happens here. So that's what the cave has to look like, right? Which makes sense. And 93 was the number. 93 units. So what happens when we run this with the real data? Let's see if this works. It's a giant cave. It's a giant cave. 27936. 27936. 27936. Good. Okay. So there we go. That's the end of today. This is kind of an interesting problem, right? It's you have a two-dimensional array is sort of the best way to solve this problem, but you need to make sure that you don't go unbounded in either direction. An alternative might have been a hash set of XY pairs, but you might have had memory issues, might have eventually had lookup issues as well with that. So yeah, this wasn't too bad. I'm not sure that I'm unhappy with the code. Like I don't the you basically already refactored the filling here, right? It's really just cleaned up all the console write lines. I think that's it. So anyway, I think that'll do it for today, and we'll see y'all tomorrow.